Example 6 gives us the following functions. F of x equals 2x squared plus 4, g of x equals the square root of x minus 4, and h of x equals 4x minus 2. We want to evaluate the following quantities or expressions. Part A says f composed with g. So we want to take the g function and plug it into f. So anywhere I see an x, I want to replace it with the square root of x minus 4. What's going to happen is if I square that, that's going to turn into x minus 4. And when we simplify this, I can distribute the 2. And this is going to end up equaling 2x minus 4. In part B, we would like to evaluate g composed with f of x, which means we're taking the f function and we're plugging it inside of g. So this is going to equal g of 2x squared plus 4, which is going to equal the square root of 2x squared plus 4. So that's all replacing x. And then we have minus 4. Now I can just drop the parentheses since I'm not distributing anything in. And if I were to drop the parentheses, plus 4 and minus 4 ends up giving us 0. So this is equal to the square root of 2x squared. Now square roots have the property that the square root of a times b is equal to the square root of a times the square root of b. So what I can do here is I can break this up into the square root of 2 times the square root of x squared. And this is equal to the square root of 2 times the absolute value of x. And there's our final answer for part B. For part C, we have f composed with h. So we're taking our h function and plugging it into f. So this is going to equal f of 4x minus 2. And then that's going to give us 2 times 4x minus 2 quantity squared plus 4. And if you want, you can expand out the thing inside of the parentheses. I'm just going to go ahead and leave our answer like this. So that's part C. So at this point, I've gone ahead and I've written out the solutions for part D and E. Now we're on part F, and we're at the point where we want to simplify the square root of 50. So this is equal to, again, based on the earlier property that we had, that the square root of a times b is equal to the square root of a times the square root of b. So because 50 can be broken down into 25 times 2, I can rewrite it like this, and then the square root of 25 is 5 times the square root of 2. So here's our final answer for part F. And for part G, we have h of 12. So what I want to do is I want to plug in 12 into my h function. And if we do that, we get 4 times 12 minus 2. And 4 times 12 is 48. And then 48 minus 2 is 46. So now we're evaluating h of 46. And so then we get 4 times 46 minus 2. And that's going to become 184 minus 2. So our final answer for this one would be 182. So there, that completes example 6 for us. Example 7 says write the following functions as the composition of two different functions. So in part A, we have s of x is equal to the square root of 16 minus x cubed. And our goal is to rewrite s of x as the composition of two different functions, f and g. So in other words, we're taking some g function and plugging it into f of x. And something that I want to point out is this actually has multiple correct possible answers. So what we're doing now at this point is we need to come up with f of x and we need to come up with g of x. One represents the outer function and the other one represents the inner function. So a possible answer for f of x is the square root of 16 minus x, and then g of x could equal x cubed because we're taking this x cubed and plugging it in here, and then that would give us the square root of 16 minus x cubed. So here is one possible answer. Can you think of another possible answer? So let's give another one, f of x and g of x, our inner and outer function. So another one is f of x could be the square root of x. What would that have to make g? Well, that would be 16 minus x cubed, because we're taking 16 minus x cubed and plugging it in for x here, and then that would give us the original function as well. So here is another possible answer that we could have given for part A. So we want to do the same thing for part B. We want to come up with our outer function and our inner function. And for our inner function, I'm going to let that be x squared, and then our outer function, that would have to be x minus 4 over x minus 1. And notice what we're doing is we're taking this and plugging it in for our input value in the outer function. And so here is our answer for part B. Example 8 says a spherical balloon is being inflated. The radius of the balloon is increasing at the rate of 0.5 centimeters per second. Part A says find a function f that models the radius as a function of time. So our function is going to be f of t is equal to 0.5 t. So t represents the time in seconds, and f of t represents the radius of the balloon after t seconds. Part B says find a function g that models the volume as a function of the radius. So this requires that you remember the formula for the volume of a sphere from geometry, and if you don't remember, the volume is equal to 4/3 pi r cubed, where r is the radius, and then in this case g of r would represent the volume of the balloon. Part C says find g composed with f. What does this function represent? So if we were to do g composed with f of t, this would equal g of f of t. So we're taking our f function and we're plugging it into our g function. So this would be g of 0.5 t, which is going to equal 4/3 pi times 0.5 t quantity cubed. And remember, 0.5 is the same thing as 1/2. And if I were to cube 1/2, that would be 1/8. And if we simplified the fractions, that would come out to pi over 6 times t cubed. And so this is our final simplified answer. Now, what does that represent? This represents the volume of the balloon in centimeters after t seconds. And that concludes example 8. Example 9 says use the table to evaluate the expressions requested. In part A, we have f plus g of 1. And using the definition that we saw at the beginning of this video, or the previous part of this video, we could rewrite this as f of 1 plus g of 1. Now, looking at our table, this first row represents our x values, and then the second row represents our f of x values, and then our third row is our g of x values. So, if I want to evaluate f of 1 plus g of 1, here is 1, that is my x value, and so f of 1 is going to equal 2. So this is 2. And then g of 1 is equal to 3. So this is 3. So now if I add 2 plus 3, that is equal to 5. So there is my final answer for part A. For part B, we have f minus g of 3. And if we rewrite this using the definition, we get f of 3 minus g of 3. So now on my table, I'm going to find the x value of 3, and f of 3 is 5, and g of 3 is 6. So this is going to end up equaling 5 minus 6, which gives us -1. In part C, we have f times g of 6. So this is the same thing as f of 6 times g of 6. So in my table, I'm going to find our x value of 6, and f of 6 is equal to 3, and g of 6 is equal to 4. And if I multiply those, we get 12. Part D, we have f over g of 7. This is the same thing as f of 7 divided by g of 7, as long as g of 7 is not 0. So let's see. Here's x equals 7, f of 7 is 11, and then g of 7 is 0. Oh look, this is undefined because we cannot divide by 0. Okay, part E is the first one where we have some composition. So we have f composed with g of 2. So first I need to evaluate g of 2. Here's x equals 2. When I plug it into my g function, the output is 5. So this is going to equal f of 5. And now I'm going to find x equals 5. And when I plug that into my f function, the output is 6. So the final answer for part E is 6. In part F, we are evaluating f of 1. So here's 1. If I plug that into my f function, my output is 2. So now I'm evaluating f of 2. So then I'm going to find 2 on my x row. And then if I plug that into the f function, that output gives us 3. Moving on to part G, we have f composed with g of 6, which is the same thing as f of g of 6. So let's find x equals 6, which is here. If I plug that into my g function, my output ends up equaling 4. So this is equal to f of 4. And then now I'm going to find x equals 4. If I plug that into my f function, my output is 1. So the final answer for part G is 1. Now we can move on to part H, which gives us f of 5. So in my table, I'm going to find 5. When I plug it into my f function, my output is 6. So this is going to equal f of 6. Now we're going to find x equals 6. If I plug that into my f function, the output is 3. And here are the answers for the remaining questions. One thing that I just want to point out is note that the thing that we are solving for in parts J and L are actually the same thing. They're just the different notations that we use for composition. So there are the remaining answers, and that concludes this video on combining functions.